Good morning. I'm drinking some juice with ice cubes. The juice remains cold until all the ice cubes have melted. You might wonder why water that has melted won't get any hotter as long as there is ice in it. Once all the ice has melted, the temperature of the liquid water rises. To understand this, let's look at today's lesson.
At the end of this lesson, you are able to explain that temperature remains constant during melting point, freezing point, and boiling point. Last lesson, you have learned about the change in state of matter in terms of movement of particles caused by the absorption and the release of heat based on kinetic theory. As a revision, let's look at the interconversion of the states of matter in terms of kinetic theory of matter. Heating. As the temperature increases, the solid particles gain kinetic energy and vibrate faster. The particles vibrate until the energy gain is able to overcome the forces that hold them at their position. At this point, the ice melts at 0 degrees Celsius and becomes water. When more heat is absorbed by the water molecules, they move even faster and gain sufficient energy to escape from the surface of water. Then, they become sufficiently active to move freely and far apart. The water boils to form steam at 100 degrees Celsius. Cooling. When steam cools, the particles lose energy and move slower. The particles lose more energy until they are closer to each other and form water. As the temperature continues to drop, the particles lose even more energy until they do not have energy to move freely. At 0 degrees Celsius, the water freezes and becomes ice. The temperature of a matter will increase when heated and will decrease when cooled. However, the temperature remains unchanged when it reaches melting point, freezing point, and boiling point during melting, freezing, and boiling process respectively. What is the temperature reading when the ice cubes begin to melt? When the ice cubes begin to melt, the temperature remains constant at 0 degrees Celsius. This is the melting point of ice. The melting point is the temperature at which a solid changes into a liquid. During the melting point, the heat absorbed is used to overcome the force of attraction between the particles. Therefore, the temperature remains unchanged during melting point. What is the temperature reading when the water starts to boil? The temperature increases as the water is heated. Boiling happens at the temperature of 100 degrees Celsius. Therefore, the boiling point of water is 100 degrees Celsius. When the water starts to boil, the temperature remains at 100 degrees Celsius even though heat is still supplied. During the boiling point, the heat absorbed is used to overcome the forces of attraction between the particles of water. Therefore, the temperature remains unchanged at boiling point. Freezing is a physical process that changes matter from a liquid state to a solid state. When the water reaches the freezing point, the ice starts to form. The freezing point of water is 0 degrees Celsius. During the freezing point, heat is released to form the force of attraction between the particles, and therefore the temperature remains unchanged during the freezing point. Next, let's look at the heating curve of water. During this solid state, kinetic energy increases with temperature. At the melting point, The temperature remains constant because the heat energy absorbed by the particles is used to overcome the forces between the particles. During the liquid state, kinetic energy increases as temperature increases. At the boiling point, heat is absorbed to overcome forces of attraction. At this point, when the kinetic energy is high enough to overcome the forces of attraction between the liquid's particles, liquids change into gaseous state. During this gaseous state, the kinetic energy increases, thus the particles move freely at higher speed.
The temperature of this icy water remains constant because heat absorbed to increase the temperature is changing the state of matter during melting point. Since the heat is used to overcome the forces of attraction between particles of ice, therefore the temperature remains unchanged during the melting process. That's all for today's lesson. Thank you.